Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's Information Week webinar, 4 Practical Tips for Building a Data Lake, sponsored by Dell and broadcast by Informa. I'm Peggy Bresnick-Kendler, and I'm with Information Week, and I'll be your moderator today. We have just a few announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. The slides will advance automatically throughout the event. You may also download a copy of the slides via the Resources widget. Toward the end of our webinar, we'll ask you to complete our survey. It's found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And finally, if you experience any technical problems, please click the Help widget found at the bottom of your screen, or simply type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. Now on to today's presentation, 4 practical tips for building a data lake. Discussing today's topic is Daryl Smith, Chief Data Platform Architect at Dell. Daryl is responsible for all database standards, platform use cases, and best practices for Dell's internal data platforms. He's been working with Oracle databases since 1988, starting with version 4, and Oracle clustered databases since version 7. Over the past 15 years, Dell has helped Dell capture and document the best practices learned from managing a global deployment of Oracle applications, middleware, and database grids, and actively engage with Dell technologies, Oracle, Hadoop, Greenplum, and NoSQL, NewSQL customers to share Dell IT's experience and platform knowledge transfer. Daryl, welcome. Over to you.
Thank you, Peggy. So hopefully today's topics will either help you get started or assist you in your growth in building a data platform or a data lake that will enable your business to really get the value of the data. Basically, in today's world, data is king. There's just so much that you can do with it, but the key to it is really just making it available, having it in a situation or having it in a platform that allows people to access it easily. So I got a couple of tips for you today. Obviously, there's many more things that you can do, and there's obviously many more technical deep dives that we could get into, but these should hopefully get you started. So we've got a very large data lake, and it's one of our platforms is the Greenplum database. I've got a few stats here from that database, but we do roughly 6 million queries a day, and 98% of those come back in under a second. And just to give you an idea, our biggest table is a couple of terabytes. We have many tables that are in the 7 to 12 trillion row range, and so that's no easy feat. And right now, our database is currently at 1.2 petabytes. That's actual data. There's no indexes counted there or anything else. By the end of this year, we're going to reach 2.5 petabytes. So it's a fairly good-sized database. And if you're not really familiar with Greenplum, I've got a couple slides or a slide that I can kind of explain to you how it works. But beyond that, we have a lot of other technologies as well. For instance, our Hadoop environment is now approaching 9 petabytes. And should be somewhere in the range of 14 to 15 petabytes by the end of this year. So not only do we have a pretty large data lake, but it's growing very rapidly. So the tips that I've arranged today are in basically four groupings, right? Enabling self-service, which I think is one of the most important things. A lot of talk around democratizing your data and making your data available to more people, not just the few in IT who know how to write SQL code. And the only way to really do that at scale and provide that level of agility is to enable self-service, and we'll go into how we've done that. The other one I think is a big trap for a lot of people, and that's what technology do you use? Well, it's not just one technology. I can't just stand up a Hadoop environment and say I've got a data lake, I throw all my data in it, but nobody can get to it, nobody can use it. It's not really of much value. So you're going to be looking at more than one technology. Greenplum obviously is a big one for us, but I'll talk about a few others that we're using. And then you need the right hardware. So if I underpower my systems, if I set it up where it's let's just say all bare metal, hand created, all manual, I'm not going to have the agility there either. So we need to look at how do we set up a more agile platform. And then the final one is really about, how do I get started? Obviously, I could build the whole thing in a day. Well, maybe take a month or two, but that's not really what you want to do. You really want to start off with small building blocks, and then as you need more, you just keep adding more. That really allows you to evolve a little bit quicker and get you to where you want to be instead of pigeonholing you in a direction that you picked 2 years ago. So let's go ahead and talk about self-service. So to give you some idea of the size and complexity and what we're enabling, I've got a logical picture here of what our data lake looks like. There's a bunch of different components. We've got the data movement tier, which is where the data enters the data lake. We've got our big data platform, the shared data platform. That's where all of the data goes. We bring everything in raw. Whatever format it exists in its original form, whether it's structured data from our ERP, whether it's feeds that we're getting off of Facebook or Twitter, it's machine data, telemetry that's coming in from the field. However it comes in is exactly how we put it in there. And we do that for a couple of reasons. One is a lot of data scientists want the raw data. They don't want aggregated data. They don't want data that's had business rules applied to it. They're looking for the raw data. The other is we've got a lot of people that have experience from those enterprise systems. And so they'll understand it in its raw format. And typically there's a lot of documentation around its raw format. And so we bring that data in raw. We'll then process it to allow other people to use it, people that are maybe experts in the business but not so savvy on the minute details of the data. So we process it to simplify it, to make it easier to access. We add business rules so that we can share that data among different orgs within the company. And in the other cases, we've done a lot of M&A over the years. And so we've got multiple ERP systems and multiple manufacturing systems. And here in the data lake, we provide a location where you can have a single canonical model so that you're analyzing your data. You're doing machine learning off of a single data set instead of doing it on two different data sets and trying to figure out how to aggregate it later on. Moving off to the right, we've got what's called an execution tier. So here's where we start to bring in a lot of different technologies, right? So big data technologies like a Greenplum, like a Hadoop, they're great for ingesting data. They're great for parsing data. They're great for operational reporting. But when I start to run and create like a predictive application, something that the sales folks could use or something that marketing could use that would predict, a good customer or a good opportunity, that really can't be supported in those types of environments. Those environments are really designed about punching through a ton of data very quickly. But when you're talking about a predictive or prescriptive type of application, or even a real-time dashboard, you need a database that really excels at consumption of the data. And that's what those other database tiers are for. And we'll go into a couple of those later on. I'll actually show you some of the ones that we're using. Obviously, the consumption tier then is how individuals consume that data. So whether it be a dashboard or a report or a predictive type application, machine learning based application, anything like that, that's in the consumption tier. Up along the top, I've got a services tier. This is really where some really neat things are happening. So this is where we're taking the data as it's being fed into the data lake, and in real time, we're running event processing on it. We're sending triggers back to and rule-based decisions back to our legacy systems. So, our really old, even client-server-based systems, we've now enabled them with machine learning, right? So, we can automatically trigger orders to our suppliers. We can automatically trigger, dispatches out to customer sites through that because we're seeing the data in real time and we're monitoring those events. All of that data, regardless of where it exists, though, is all managed through that same metadata security and governance framework. I'll have that later on the slides as well. But basically, it's where is my data? That's the metadata. Where does it exist within the data lake? How do I get access to it? That's the security and governance piece. Can I push a button and be granted access to the data that I found? to make it easier for data analysts, machine learning, data scientists, excuse me, to get access to the data that they're looking for that they need to do their job. Right? Again, if it's all just dumped into some big data platform, nobody's going to get any use out of it because what is where? Nobody knows. The one thing I want to point out on this slide is I've got little red asterisks all over the place. Those are where we've enabled self-service. And that's, to me, king. The only way to really be agile is take some of the development, some of the responsibility away from the supporting IT staff and move it out into the business, whether that be, other groups within IT that are supporting individual business units or consumers in the business units themselves, being able to get access to their own data and push their own priorities, right? Because IT typically, is governed by budgets and, lots of process. So the business is not. So how do we enable that self-service? Self-service, I've got a couple of diagrams. They're a little bit fuzzy, but over on the right-hand side, it really kind of comes in two forms. One is really streamlining the approval process. So if I want to get a workspace within one of the big data platforms, if I want to stand up an individual execution tier or whatever, maybe I need to fill out a form and provide a justification because there's limited resources. Or all the way back to, fully automated. We've got this thing called the digital cloud where I can order up a database, I can order up some middleware, I can order up some analytical tools, simply by clicking a button, and as long as I meet certain criteria, it'll automatically be provisioned. And I'll just simply receive an email that says it's been provisioned, here's your login credentials, have a nice day. And that requires, in the simplest form, it could be some back-end scripting. So if I've want to get access to the Greenplum database, I want 5 terabytes of storage out there, I can fill out a form. That's the one that's a little bit farther in the back. And as long as, I'm in a pre-approved group, they'll generate it right away. If I'm not, they may need to do some research. But it's all about streamlining that approval and doing the back-end scripting so that I can ask for it in the morning and have it by the afternoon. That's really providing us the agility that we need to roll this out to the business and the business to be very, very successful with it. And then, there's tools and data. So I need to get the tools to be able to access the data, but I also need to be able to get the data. And I'll talk about that a little bit more later on. But access to the data through self-service is absolutely critical. Typically in today's world, data scientists spend 80% of their time just collecting and curating the data before they even start to run their models or their algorithms against that data. So if I can make that simpler, I can make them a lot more productive. But as always, there's always barriers to moving forward. The big barriers for self-service is just simply the number of resources that you have available to you. So, within your data center, you've got X number of servers, you don't have more. You can't just buy more whenever you want to. And so that can sometimes be a barrier. We try to stay ahead of that. And what we do is we'll actually have always a little bit of extra resource to make available for those groups that didn't have the funding, something that comes up in the middle of the year that we thought about, so that we have the ability to expand and utilize any unused resources within the data lake to make that available. Obviously, funding solves resources, but one of the biggest barriers that I've come across is just loss of control fears. So, me in IT, I fear losing the amount of workload that I'm being given. As a manager, I've got maybe 10 employees, I've got 100 team members. If I let other people do that work, then that's going to reduce the amount of work that I'm going to get, and I'm going to have to shrink, right? So there's lots of fears around there. We haven't really seen any of that. So what we've really found is that the more access the business gets to the data, the more that they need or realize that they need individuals to help them with that, especially people who know the data, who know the tools, and who know how to develop. So we've actually seen a big increase in the demand for IT resources to help the business, in the very least, to jump off and get started, but more importantly, though, to augment their own team and help them build solid, stable processes. So those barriers, they can be overcome. It can be somewhat difficult, but it's something that you've got to push for and try and stay ahead of. As I mentioned, data is the other big one. It's maybe even bigger than the ability to do self-service, because if you don't have the data, you can't really do anything. So there's this term now that's coming out similar to DevOps called data ops. And data ops is really the ability to get to your data easily and quickly, really to remove the barriers to finding that data and getting access to it. But ultimately, the answer is self-service, right? And self-service with automation is how you provision. So I need to be able to find the data. I need to be able to request access to the data and ultimately be granted access to the data and told where to get it. We have that fully automated within Dell IT today. And it's been a huge forward mover for the work that we're doing. And again, it's about self-service. So, how do we get the data? How do we know what data is coming into the lake? There's plenty of ways you could do it. You could track it on Excel spreadsheets. You could put it up on a Confluence site or SharePoint. There's any number of ways you can do it. We try to do it automatically, so that not only do we get what data is in the lake, but we know where it came from. And so, part of the reason we picked some of the tools that we use, like Kafka, like StreamSets, which is a data ingestion tool, and Calibra, which is the metadata tool, is because they interact. So if I create a Kafka topic, that data automatically gets put into Calibra. And that's done through Cloudera Navigator, and then Calibra's connection to Cloudera Navigator. Same thing with StreamSets. That data automatically gets put into Calibra. And so I've got data, I'm pulling it from the source system, so I know where I got it from because StreamSets has reported that to Cloudera Navigator, which then goes into Calibra. I've got the data that persists out on a Kafka, right? So now I've made that lineage jump from Kafka. That data using StreamSets could go pretty much anywhere else in the data lake. All of that lineage is all there too. So when I have that piece of data that's been brought in, I know that it came in because it came in through Kafka and StreamSets, which are two of the technologies that we use. So I know that the data came from this manufacturing system, and it went to Greenplum, it went to Hadoop, it went to a Postgres database in the consumption tier. So all of that data is now available in Calibra for me to go search and find, and then request access to it. So just to give you a snapshot of what Calibra looks like, or some of the capabilities that we use, or that you would want to use, regardless of the tool sets that you buy. Right? Obviously, I'm suggesting some tools, or I'm mentioning the tools that we're using, but there's lots of other tools in the marketplace that you can do this kind of work with. But it's absolutely critical that I can find my data. Right, so I can do that. I can search for the data in Calibra. There's this concept of published versus unpublished. All the data, for the most part, has lineage. The exception to that is data that I've curated from within the data platforms themselves. But to publish a data set, you've got to have that lineage included. You've got to have a description of the data set. Otherwise, it's a private data set. You can't share it. So data quality is a big one. We've been talking about data quality for many, many years, and it continues to be a talking point. But it does become important as more and more people try to use that data. Right? If I'm in, let's say, sales, and my sales data is kind of junky because my address is all messed up, but I'm used to it, that's okay. But if I want to share that data, they don't know the rules that we've been living by. So it's important to really start cleaning up your data as you begin to share this between different groups within the company. And then the other important concept here is who owns that data. At Dell, the owner of the data is the owner of the business group that created it. Right? So if we've gotten the data from an application that supports sales, sales owns it. In some cases, those business units will defer to their IT teams to manage that data stewardship or data ownership, and that's the person who will grant you access. Sorry about that. And so it's important to identify who that data steward is, and so that they keep track of that workflow, because when I find the data that I want in Calibra, there's a button that says I want access. And a justification will come up, and you can fill it in or not. But when that gets routed to the data steward, he's going to look at that to make a decision, do I grant them access or not, and for how long? So that obviously that'll help. Once he's granted them that access, that's when the automation kicks off and goes ahead and provisions the access to that data, and then sends an email to the the person that requested it, and they said, this is where your data is, this is how you access it, have a good day. That's how all automation or all self-service really should work. So let's move on to you need more than one technology. I've mentioned that before, but it's absolutely critical. You can see from the diagram, I've replaced the logical grouping with some of the technologies that we use. This isn't a complete list of the technologies, but it is some of our most popular ones. What we're going to kind of focus on more today is our bigger data platforms. Obviously, I've talked about how Kafka, we bring the data in using stream sets. We also have Boomi for our external sources. But the data comes in two places. All of our structured data comes into Greenplum, and all of our unstructured or semi-structured data goes into Hadoop. Obviously, there's some exceptions. We do have some structured data in Hadoop, but Greenplum, being a relational database, has much faster, or gives you much faster access to curating the data than you could if you stuck all of these tables out into an append-only file system with no database optimizer, right? Use Hive or whatever. So that's why we use Greenplum for all of our structured data. And that unstructured or semi-structured data, generally the purpose of that in Hadoop is to find that structure. Whether I find it just using basic machine learning, or I use parsers because I actually know what the structure looks like underneath. That's what Hadoop is one of the primary reasons for, right? The other one is once a data scientist has discovered that data, they've gone into Greenplum and found the data they're looking for. They've potentially added some data quality rules, fixed it up. They've created that data set. I can then just dump it out on Hadoop because when I go to run my algorithms against it, I can pull that data off of Hadoop super fast. And by the way, it's a fairly cheap way to store your data to give you that kind of speed. So those are two big data platforms that we deal with. Again, Greenplum being the default. As I mentioned, we're at over a petabyte today. We'll be over 2 petabytes by the end of the year. So that's extremely helpful. And that's where the bulk of our analytics and data scientists spend their time looking for data. A couple of examples of what's going out in the execution tier. We've got in-memory databases. We have graph databases, object databases, regular relational databases. It's really all about the consumption. If I wanted to put 1,000 users against a Greenplum or a Hadoop and expect them to have decent response times, I'd be losing my mind. Which is why we'll take a subset of that data. Maybe it's a transformed data set. Maybe I'm keeping that data up to date with some real-time feeds like inventory numbers or sales numbers. I can then support 1,000 users, 2,000 users. I could support 1 million users with some of these execution tiers. And so that's really all about the consumption of the data at the same velocity that I can ingest it into my shared data platform. So it's very important that we don't pigeonhole ourselves and say, I'm going to stand up a Hadoop environment and I'm going to do everything on there. Because I'm not going to be satisfied, and I can't support 70,000 users on a single Hadoop cluster, even if it's 1,000 nodes. It's just not going to perform for me, and it's not going to provide a user experience. I think this is one of the reasons why a lot of people are searching for cloud, is because they think that there's one tool out there that's going to give them what they want. But even if you were to go to cloud, you're still going to be talking about multiple tools for multiple different personas. So I promised, and I'm going to go into it for those that are not familiar with Greenplum, or even I guess those that are. It's an MPP database, massively parallel processing. It uses shared nothing architecture, so basically all of my data gets broken up and subset into a bunch of different smaller Postgres instances, and that's what they're based off of. Is Postgres, and every release of Greenplum comes against a newer version of Postgres. So they benefit, as Postgres goes in the community, Greenplum benefits from all of those advancements, which is kind of cool. But basically, as I said, if I've got 10 segments within my Greenplum database, I'd break my data up into 10 roughly even chunks and split it across those 10 different segments. And so when I issue a query, all 10 of those segments are going to issue the same query against their set of the data. And so you can imagine, if I've got 1 million rows and I've got 1,000 segments, each one of those is only querying a small subset of that data, and so it comes back super fast. Our big database, that 1.2 petabyte one, we're close to 2,000 segment instances. And so that's why, even a trillion row table comes back super fast. So most of this all happens without a whole lot of thought. You can certainly put a lot of thought behind it. You can shard your data in any way you want, or completely random. And so, Greenplum really relies on the power of the I/O to do the work for you, versus having to index or carefully shard or carefully partition. And so, having a database that can do a terabyte per second of I/O obviously is going to help that. And that's where we're currently at today, or a little over a terabyte per second we can do. Once we're up to that 2.5 petabyte database, our Greenplum is actually going to be capable of 2 terabytes per second of I/O, which is a little fast. And you basically build this out in building blocks. So if I've got 24 nodes of it, and that gives me a certain amount of storage, and I need more storage, I'm just going to add more nodes, right? Because you're going to keep that same balance of CPU to I/O. Those things really don't change. If you want to do archiving, I've got a slide about archiving later on. But you can put data out into another form. I could put it out in Hadoop, for instance, and still read it from Greenplum. So if you want to expand your storage that way, you're good. But if you've got a million row table, and you use 10 CPUs on it to query it, and it comes back in a certain amount of time. If I've got a 2 million row table and I double the number of CPUs, it's going to come back in the same amount of time, right? So you don't want to get out of that balance. Along with having multiple tools for consumption, so we've got like Power BI, we've got Tableau, we've got other tools, and I can't think of off the top of my head. Bob J, for instance. Same thing is true in the data science world, right? No two data scientists is the same in their desire, in their capability level, or in their understanding of the data. And so we have a lot of different requirements. Most of them have some similarity. I need to track and version my models so that I can see if I'm getting better or worse as I add and remove data sets. I like this tool versus another tool. And so, we've got a fully supported 24/7 mission critical platform that we get from Cloudera called Cloudera Data Science Workbench. As you can see, it's got a lot of support for different packages and different editors and languages. But not everybody wants to work in that environment. Other people want to try new things. I want to try H2O, for instance, which is, more of a tool for a citizen data scientist, where you really only know about the data. You don't really know about algorithms, and so it does brute force testing on them. And that's not something that IT supports, and so I can try this out in what we call an innovation platform. And so that's just essentially Docker containers running within PKS, or Pivotal Container Service, currently known as VMware Tanzu. Or we've got a flat-out Kubernetes cluster, which we've added some GPUs in. Or within Cloudera Data Science Workbench, you can do it as well. We've got CPUs and GPUs there. But lots of different options. The one on top, we fully support from IT. The one on the bottom, it's kind of a wild, wild west. So if you can make it work, that's great. If you can't, we'll try and help you, but we don't have any guaranteed SLAs there. Because ultimately, and I'm sure a few of you have been thinking about this, how many different technologies can we really support? And we can't support all of them. It's just not possible. So we have to limit it down to some smaller number of very capable tools. But utilizing vendor support, we can extend that quite a bit. Much like you would support for an Oracle database or SQL Server database. All these other databases, as long as you've got vendors to help support them, then you can bring those technologies up and running and gain your experience in them over time. But the worst thing you can do is say, I'm only going to support 2 technologies, and so that limits you in what your data discovery can look like, or what your data insights can look like from the data in your work. So the next really is the right hardware. So if I mentioned earlier, if I underpower my platform, or I've got technology that's not agile and doesn't let me respond to the changing requirements of the business units, or of the people that are utilizing the data, I'm not going to provide that agile environment that I need, because in the data world things change very, very rapidly. And so I really need to think about that hardware and how I can be agile while building it out. So this is kind of a picture, kind of got a little ugly there, but this is what our infrastructure looks like, right? So we're very much standardized, in terms of our virtual environment and our physical environment. But basically, our Hadoop environment is made up of PowerFlex, running our Hadoop compute nodes virtualized, and then Isilon or PowerScale actually running our HDFS. That gives us a bunch of different benefits, some of which include, being able to do snapshots, so I can back up my data. Just imagine trying to do a backup to some backup media, and you got 9 petabytes out there with no change tracking. It just becomes impossible, and most people don't back up their Hadoop environment at all. We do it actually multiple times a day. And so I could, in an individual directory, if somebody messed up, human error or bad code or whatever, we could restore that directory in a matter of minutes. So there's lots of advantages to that. We also separate our compute and our storage, right? So I can have 12 petabytes, and right now we only have 88 Hadoop nodes that are supporting that 12 petabytes. But if I needed some more compute to do that, I'd just stand up some more compute virtual machines, and I've got the compute and the memory that I need to support that. All of them are built out, regardless of whether I'm running a virtualized Hadoop or I'm running a virtualized stream set or Kafka or an in-memory database single store, or any other technology. It's all running within those same ESX clusters. And so as I need more resources, I just simply say, and again, you could put your server config here, but I just buy 2 more of the server configs, right? We use R640s, highly dense, super great. But I tend to buy them in blocks of 16, but I bought them in small as blocks of 2. I just keep adding more. As you can see, we're up over 350 servers now in that cluster, and we're supporting all kinds of different technologies, just a few of which are listed here. We also have a Hadoop cluster, not a Hadoop cluster, a GPU cluster, excuse me. We're actually up to around 14 GPU servers today. That's 28 GPUs, fully virtualized, which lets me support, what am I up to? 24. That lets me support 48 concurrent GPU requests with no, negative overhead. So very, very capable platform. Same thing with Greenplums. We're using R940s, certain size. If I need more storage or if I need more compute for that storage, I just simply add in more blocks, plug them into the switch, and we expand very rapidly. So this is going to be important later on when we talk about how we can grow, how we can start small and grow. We'll come back to that, but basically we've got a fairly simple infrastructure that's easy to maintain and easy to grow. I did want to mention this, the archive. I kind of mentioned I'd talk about it later on, and this is now. With the Hadoop environment, it allows us to very easily provide a self-service archive. Most of the data platforms out there today either talk to HDFS or they will be. I realize that Hadoop is a technology that's becoming less and less popular, and for very good reason, but it's still very powerful to do several things, right? Obviously, aggregating log files, parsing log files, parsing telemetry, and archive are all very efficient. And so with our Hadoop, with our PowerScale, I go directly to the HDFS. I don't even actually go through Hadoop. But databases like Oracle, like Greenplum, Postgres, SQL Server, and many others, single store, can write and read directly from HDFS. So imagine I can create a table in my database. I can access it just like it was a table in a database. But when I put data out there, it actually gets stored out on either a PowerScale unit, an Isilon, or an ECS, for like pennies on the dollar. And by enabling that, I don't have to go through the process to be concerned, could somebody possibly need that data down the road? Because if they do, they just pull it back. It's still available to them in the database. And so this allows us, again, to scale out our storage needs, or the amount of data that we're capturing within our data lake, without necessarily having to put it on very expensive platforms or even medium expensive platforms. Excuse me. And we're rolling this out to the entire enterprise, right? So for Oracle, SQL Server, Postgres, and other data platforms, instead of going through a process where I have to write an extract of that data and then I have to put it in a form somewhere that if I had to, I could access it, but it's not easy, or it takes an act of God to get it back. Here's a very simple way to do it, which puts all the onus on the business units or even the other IT units. And by the way, if you've made a mistake, it's no big deal. It's still available to you. So it's allowed us to be a lot more aggressive. So we've talked about self-service. Very, very important to be agile. It's very important to open up the capabilities to more than just your IT folks, but to the rest of the business, or certainly outside of just the data org to other IT groups. You do that through self-service. You obviously and most definitely need more than one technology. I've never seen anything in the world, whether it be an automobile or an operating system, where you can have one that did everything. I just can't even imagine taking my Ferrari to the dump to get rid of my, my waste. That would be insane, right? I use my pickup. Same is true with technology. We need to definitely find the right tool for the job. And then you put on the right hardware. You can be as flexible as any cloud company out there, simply by either virtualizing, containerizing, putting it into a technology where you don't waste the resources. I can share those resources, I can overcommit those resources, and I can scale and burst with the best of them. Especially when you're talking about over 350 servers worth of resources that are interchangeable. That's pretty powerful. But I can't build it all today. That would take me forever. So I want to start small. And this is what we did. We started many years ago, and we decided on the type of infrastructure that we were going to do. And we decided we were going to build it modular. And so we spent some time. We figured out exactly what our server unit was going to look like. Again, for us, it's an R640, a Dell R640. For you, it could be something else. But find a component that works, that'll scale, that meets your storage versus CPU versus memory grouping. And you just buy some number of them. Buy 16 of them. Buy one ESX cluster worth of compute, storage, and memory. And again, this could be on PKS. This could be on some other virtualization technology. You want to be a little bit careful because they're not all equal. And build it, right? And then I could stand up a few nodes of Hadoop. I could buy a few PowerScale nodes and start off with a small Hadoop. Buy a few Greenplum nodes, start off with a small Greenplum database. And then as your requirements change, maybe you need a little bit more Greenplum because, like for us, we stood up a few nodes and everybody wanted to jump on. And so, we scaled from 12 nodes, up to 128 and beyond this year. We're going to get to 140 nodes this year. And this has only been over the last, about 5 years. So, build it and they will come. They certainly did. And so, you add a few more nodes. You add a few more virtualized nodes or container nodes, whatever. You add a few more Greenplum nodes, add some more Isilon. They're building blocks, so it's very super fast. I can get new ESX servers in, as little as 3 or 4 weeks. The Greenplum ones take a little bit longer because they're NVMe based. But, you just simply add them as you need them. If I need more storage, add more Isilon. Maybe I throw on an F810, which is an all-flash Isilon node because I need the speed, or maybe I use an H500 because I need the storage, or maybe an ECS because I need to do more archive. I add it as I need it. And you can just keep growing that out. So as I mentioned, we're up to 354. Well, it's more than that. So that's why the plus is there. This number, as soon as I write it down, is out of date. But we just keep growing and keep expanding. Obviously, there's going to be some point maybe in the future where we stop growing. But the beauty is that these first servers that I had put up, they're going to go end of life at some point. And as they go end of life, that's fine. I can just put them in maintenance mode. I can add new servers into that cluster. Take the old ones out, and I've just upgraded, right? So, I can continue to just swap out the infrastructure as it starts to age. Again, a beauty of going with the modular approach. Basically what we've talked about, I mentioned it before, the self-service. I can't go into how deep and how important that is. IT usually does is says, no, we can't do that. And that will, turn people off and turn people either out to do their own thing, which is probably the worst thing that can happen, or, put together something that people just can't use, which maybe that's even worse. So that'll really revolutionize your business by enabling those end users to do it. Each use case that we've got, and we've got a lot of them. I mean, we've got use cases that stretch from when is my hard drive going to fail, or when is a bunch of hard drives going to fail, to, what type of events are going to create a customer to be unhappy and deserve some attention, to, who within the company is a high potential that we could potentially lose based on what's happening in the industry, what's happening within their own organization. And so, we've got people in HR that are doing machine learning. We've got people in product engineering that are trying to improve the product. We're doing a lot of it in marketing to figure out who we should market our things to. And so, all of those different use cases require different technology, right? We can't just do that with just a Hadoop environment. And I realize I've said this several times, but hopefully it's going to sink in because it's super important. Don't need to go into the right hardware again. We've really covered that well. Starting small and growing, this is one of the things that really stops a lot of people from even getting started is, you figure you've got to build it all in one day. I have 10 petabytes of data, and I got to get it in there tomorrow. Well, that doesn't really make a whole lot of sense, and it's going to stop you from even getting started. So think about, well, I'll put a petabyte in, and we'll start to use it. I'll put maybe a fifth of the data in and start to use it. I'll put a couple of, key tables that everybody keeps looking for in. And that's really how we get started. As I mentioned, we stood up something small, and it just it grew by itself pretty much. And so we didn't try to build it in a day. We're much better off evolving over time. And the other reason for that is because the requirements evolve. I may have a requirement today just to do a sales forecast, but then that leads into an opportunity forecast, which leads into a marketing opportunity, which just keeps adding up. And so your requirement of day one isn't going to be your requirement, 6 months from now. So it's good to evolve over time. I'm not going to mention self-service again. I think I've really kind of hit that with you. We have, as a company, we have a lot of information out there on how to get started and the different technologies that could get you started. Other companies have the same. There's a lot of information out on the internet. There's lots of blog posts. Don't believe them all. So, I find that and I fight that quite a bit within our own companies. Somebody reads a blog post, someone claims that technology A is super awesome, it does everything you could ever want, and it scales to something unlimited. But when you start to dive into it, well, those truths aren't really true. And in many cases, you actually have to be quite an expert at that technology. And I'm not going to name any names, but and if you're not a super expert at that technology, it's not going to scale past a terabyte. So it's there's a lot of good information out there, but there's also a lot of bad information out there. But use your own common sense and certainly connect with other people who've been successful. And use what they've learned instead of starting everything from scratch. So hopefully that's a good enough start for you guys. I do see that there's been some questions that are coming in here, so I think we'll move on to Q&A. Certainly, feel free to ask any question that you want. If I don't end up having enough time to answer them, we'll try and do something about that. But let's go ahead and get started.
Okay, thanks so much, Daryl. Before we begin with today's Q&A, I'd like to ask our audience to please direct your attention to our webinar survey. It's available on the right of the presentation window. If you close the survey, you can reopen the widget by clicking the icon along the bottom of your screen. We thank you in advance for filling out our feedback form. Your participation in this survey allows us to better serve you. And now on to our question and answer. Here we go. Let me see. What tools do you suggest to measure data quality progress and to track critical data elements?
That's a great question. So I did have up on the screen that we use Calibra to track our data quality. There's no innate data quality capabilities within Calibra, but you can set up KPIs. So you can put a KPI that tracks the number of let's say street addresses that don't match the street database. You can say the number of them that have special characters in them or things like that. You can set up the KPIs within a tool like that, and there's quite a few of them out there that measure the quality of the data as it comes in. We, for many, many years, tried to maintain the data quality in the data lake by processing the data after it hit the lake. And we finally got to the point where we decided it actually makes a lot more sense to go at it on the source systems. And so now we're actually measuring the data quality from the source system and not just from the data lake. But hopefully that answers that question.
Great. Thank you. Here's one more. In your data lake, what capabilities, if any, are available to analyze data in an encrypted form without revealing the plain text data?
Analyze it in the encrypted form. Well, that's interesting. We generally decrypt it to analyze it. We do have some technologies that we've got, and it's specifically for legal rules around the world where certain customer information is not supposed to or shouldn't or can't leave that geographic area, and so they basically get it's not like a checksum, but it's a instead of Mike, it's A, B, C, D, E, F. So it takes certain common names and just translates them to some random name. And so the data they get back is skewed, but to read the results you have to use the same key that you use to encrypt them. But it's very, very complicated trying to do that. You're better off as part of the algorithm to decrypt the data during the algorithm phase, and then re-encrypt it when you send back the results.
Okay.
So no one actually sees the decrypted data.
Okay. Good. In a system of this scale, how often do you need to replace a disk, a memory card, a CPU? And how do you migrate the workloads of a system where you're replacing a hardware component?
Yeah, that can be a huge challenge. So within Greenplum, there's this concept of primary and mirror. So there's two copies of the data, and the two copies exist on different servers. And so if we lose a server, and this does happen, especially if you've got 128 servers, you're occasionally going to get one that goes down. Where the mirror is, we'll take over the processing until such time as we get the original server repaired. So we actually tend to lose memory more than anything else because we thrash the heck out of it. It's not like memory in your laptop where it stays pretty consistent throughout the day. Those bytes are just on and off all the time, and so we do tend to lose some memory boards. Good thing is that the latest firmware within all the servers, those memory boards now will self-correct. And so, having an outage for a memory issue is pretty much a thing of the past. I can say we haven't lost a CPU up to date. We have lost several drives, but they're all hot swappable. So, that one mirror will fail over, and we'll swap out the drive, rebuild it, and we're back up and running. Same kind of thing exists for Hadoop and for our things like our Postgres execution tiers. We've got multiple. We've got Postgres clusters where we've got multiple readers and one writer, and so we build failover and Ultra HA into all of our big data solutions.
Okay. What's been your experience with Intel Optane non-volatile memories, and how do you use them in your system?
Did that question come from Intel?
Could be.
It's a great question, yeah. So we're still in experimental phase. There's certain features within the big data platforms where super high fast disk is extremely helpful. We're looking at moving that capability up into the Optane so that it no longer becomes a bottleneck for that platform. You could think Postgres has a little problem with the wall files, for instance. So using that type of memory architecture can be a big boost for us, but we don't have it currently enabled in the data lake.
Okay. Our questioner wanted to make it clear that this is not from Intel. So I just thought I would add that. Thank you. Okay. Do you have any issues with different analytics software or tools conflicting with one another? How do you handle that with so many different applications and tool sets?
Yeah, that's a great question. So we don't we don't really have a problem with two different tools accessing the same data, but I don't think that probably was the question. What we do have is a problem where we've got 6 different people that each want to use 6 different tools that does the same 6 functions. That one's a challenge. We actually have a very strict process within Dell. It's called the TAGS process, the Technology Assessment Group, something or other. And I'm on the board of that, and we evaluate which technologies that we're going to allow to run within, not only within the data center, but anywhere in the cloud. And it's all about security and ease of use and supportability and stuff. So that's one way we kind of manage the different technologies that are allowed. But beyond that, since we're highly virtual, we do have very, very active container systems. We can run these tools side by side without really conflicting too much, as long as they support the same protocols. Right? So if you're speaking HDFS, I don't care if you're Oracle or if you're Greenplum or you're Hadoop, you're supporting the same protocol, and so you tend to work fairly well with each other. The only time you can get into trouble is if you've got a technology that you don't have resource management on, so you can't limit who gets access to the resources. Then you get a noisy neighbor issue, and someone can essentially give you a denial of service to your data.
Yeah. Interesting. Good. Well, there are 2 questions related to growth, so I'm going to combine them. Any specific recommendations for us as we grow? Great tips you can share? And are there any gotchas with growth that we need to be aware of?
Yeah, so my biggest gotcha is not really any much of a problem, other than a lot of our administrators are super helpful, and they want to give away all of our resources to all the good people who want to use it. And so staying ahead of having some excess capacity for those really deserving use cases, or emergency. Hey, we're at the end of the month and we didn't think this was going to happen, but we suddenly need 100 more CPUs or 6 terabytes of memory or something. Trying to stay ahead of that is the biggest challenge that we've got. And in some cases, as long as you've got reasonable workflow management, something that you can manage really well in VMware, not so well within Kubernetes, is the ability to prioritize one group or one workload over another. And so we've been very, very effective in utilizing all of the unused resources in our clusters for those that, really hadn't planned properly. And I just come up with, well, I have this idea and I want to try it out. And so I want a POC, or I want to try before I buy. And we say, okay, great. You can have access to all the resources you want that's currently available, right? So if all of the planned customers were doing their workload, they get 100% use of the system first. But if they're off getting a cup of coffee, you can sneak in a query or 2. So that's pretty much how we manage it. The gotchas is if you can't manage that and you let that get out of control, then your priority, your super important workloads are going to be impacted by, hey, I'm just trying something out here.
Okay, good. Do you provide capabilities for scoring machine learning models in user-defined functions right in your Greenplum, and store the scores right in the tables to avoid moving data out of Greenplum?
Yeah, so one of the capabilities I didn't cover in Greenplum is its ability to actually do machine learning. So as long as your algorithm is supported by the MADLib libraries, you can do some, highly parallelized machine learning right within Greenplum. Where you store your results at, it's pretty much up to you. We do have data scientists that store them directly in Greenplum. The data never leaves, and nor does the result. We have other data scientists who, choose to pull their data out of Greenplum, put it on Hadoop, do their storing, and then score that back into Greenplum. But generally, if you're talking about the accuracy of the score, that tends to be stored in GitLab along with the algorithms so that they're tracking their versions and success rates. If you're talking about the result set in terms of, what is the likelihood under scenario A, B, and C that someone's going to buy D, those tend to be stored in a database and utilized at runtime.
Okay, good. How do structured databases and unstructured analytics platforms work together?
Well, that's a great question. So all of our structured databases these days have the ability to accept some unstructured data. And so in a lot of cases, if I've got structured and unstructured data that are related and mixed, we might be talking about putting something like that into a Cassandra database. Like a lot of our telemetry goes into Cassandra, where we've got, say 6 or 8 or 10 columns that are stored in columnar format, and then basically this big blob at the end. Or you could store it, JSON or BSON in the case of Cassandra. But generally, when you're doing something like that, you're really not mixing that data with other data sources. So take, for example, some of our dial home data that comes in and basically reports that you've got a drive that's about to fail, or your temperature is not consistent with best practices or whatever. If that data is stored in a blob or a clob, in a JSON format or whatever, it's not data you can share and act upon. And so what we tend to do is we parse that out and put it into a structured field in a structured database. And that's really how it's consumed.
Okay. We are just about out of time, but I do want to ask you, Daryl, if you have any parting words, any lasting messages you would like the audience to leave our session today with. Can you share your final parting words?
I have two.
Okay.
I have two. One is keep it as simple as possible. The minute things get complicated, people get confused and stuff breaks down. And the other one is, start. Just get started. Start small and grow. Pick a use case. Maybe an easy use case. Find your technology, build your standard size, or even just POC, and just get it done. What you'll find is, the more people that learn about what has been done and how easy it was, especially, the more data that you add into that platform, the easier the next person coming along sees it, the bigger it's going to grow. But don't get stuck, in I've got all this data that I can't really access too well, and so there's nothing I can do about it. Take it out, put it somewhere that you can access.
Terrific. Thank you, Daryl. Information Week appreciates your time and expertise on today's topic. We want to thank our sponsor, Dell, as well as everyone in the audience. We appreciate your attention and participation. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been available to listen to the event. This webinar is copyright by Informa. The presentation materials are owned by or copyrighted by Information Week and Dell, and the individual speaker is solely responsible for his content and his opinions. On behalf of our guest, Dell, I'm Peggy Bresnick-Kendler. Thanks for your time, and have a great day.